Hello, good day. My name is Reyes from the section of E11I, and today I will teach you about the concept of rational functions. First of all, what is a rational function? A rational function is one that can be written as a polynomial divided by a polynomial. Since polynomials are defined everywhere, the domain of a rational function is the set of all numbers except the zeros of the denominator. It is denoted in the form of f of x is equals to p of x over q of x, where p and q are both polynomials. Q of x, which is the denominator, must not be equal to 0. It will be undefined if the p of x will be 0 and if the numerator has an exponent that is a fraction. It won't be computed and still be undefined. Examples: x squared plus 3x plus 2 over 0 is not a rational function, since the denominator is 0. X raised to 1/2 plus 3 over x squared is not a rational function. The exponent is a fraction, which makes it undefined when calculated. X squared plus 4 over x plus 3 is a rational function since the denominator is not equal to 0 and the exponent of the numerator is not a fraction. This is the concept of rational functions taught by Reyes from the section E11I. Thank you.
Rational equation. A rational equation is an equation containing at least one fraction whose numerator and denominator are polynomials.
This is one example of rational equation.
This fraction may be one or both sides of the equation. A common way to solve this equation is to reduce the fraction in the common denominator and solve the equality of the numerator. While doing this, we have to make sure to note cases where indeterminate forms like 0 over 0 or 1 over 0 may arise. Rational inequality. A rational inequality is an inequality that contains a rational expression. When we solve a rational inequality, we'll use many techniques we use solving linear inequalities. We especially must remember that we multiply or divide a negative number, the equality sign must reverse.
This is one example of rational inequalities.
Graph of rational functions. Rational functions are the form y is equal to f of x, where f of x is a rational expression. This is an example of rational function. The graphs of rational functions can be difficult to draw. To sketch a graph of a rational function, you can start by finding the asymptotes and intercepts. Steps involved in graphing rational functions. The vertical asymptote of a rational function is xx value, where the denominator of the function is 0. Equate the denominator to 0 and find the value of xx. The vertical asymptote of the rational function is x is equal to negative 0.5x equals negative 0.5. This function has the x-intercept at negative 1/4 and 0 and y-intercept at 0 and 1. Find more points on the function and graph the function.
Table of values. A table of values can be created to sketch the graph of the function. Example here is f of x is equal to 4 over x. First step, we will find the domain. Our domain here is x such that x is not equals 0, since all real number except the 0 can be substituted here in our given. Next is making the table of values. Here we have x is equals to 0 in the middle, and we will find all the closest number to the 0 and we will substitute it in our given. And here is our answer after we substitute all the number to our given. And since our 0 is x, our y will be undefined. And that's how you will make the table of values.
Hi everyone, this is Josh Reyes and Sorreda for the horizontal asymptotes. So horizontal asymptotes can be determined by comparing the degrees of the polynomial found in the numerator and the polynomial in the denominator. Firstly, if the degree of the numerator is less than the degree of the denominator, then the x-axis is a horizontal asymptote, which means that the horizontal asymptote will be found in y is equal to 0. For example, we have r of x is equal to 2x raised to 1 plus 2 over x squared minus 3x plus 4, wherein the degree of the top or the numerator is 1 and the degree of the bottom or the denominator is 2. We can see that the degree in the numerator is less than the degree found in the denominator. Secondly, if the degree of the numerator is equal to the degree of the denominator, then there is a horizontal asymptote. We need to look at the leading coefficient of the numerator and the leading coefficient of the denominator. For example, we have r of x is equal to 2x squared plus 4x plus 5 over x squared minus 3x plus 4. As we can see, the degree on the top or the numerator is 2 and the degree of the denominator is also 2. Now we need to use the 2 and the invisible 1. We will divide it. 2 divided by 1 is 2, which means the horizontal asymptote will be found in y equals to 2. Lastly, if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote, but rather an oblique asymptote. For example, we have r of x is equal to x cubed plus 2x squared plus 4x plus 5 over x squared minus 3x plus 4. Wherein the degree of the top or the numerator is equal to 3 and the degree of the bottom or the denominator is equal to 2, which we can see that the numerator's degree is greater than the degree found in the denominator. So that is it for determining the horizontal or oblique asymptotes. Again, we just have to compare the degrees of the leading coefficients of the numerator and the denominator in order to locate where the horizontal asymptote will be found, or if there even is a horizontal asymptote. That is it. Thank you for watching.
Hello everyone, this is Sean Derek Rafols, and now we'll talk about inverse relations. First, let's know the definition of an inverse relation. Definition: an inverse relation maps the output values back to their original input values. This means that the domain of the inverse relation is the range of the original relation, and that the range of the inverse relation is the domain of the original relation. So in other words, an inverse relation is a set of ordered pairs which are obtained by interchanging the first and second elements of the ordered pairs of the given relation. So how to find the inverse of a function? To find the inverse of a function that is given by an equation in variable x and y, switch the roles of x and y and solve for the new y. Example number 1. Given y equals 5x minus 3. So, find the equation for the inverse of our given. First, we will write the original equation, and then we will swap the variables. So from y equals 5x minus 3, we will change it to x equals 5y minus 3. Now, we will solve for the equation which is x equals 5y minus 3 for y. And the answer is y equals x plus 3 over 5. Example number 2. Find an equation for the inverse of the equation y equals 7x minus 4. Like the first example, we need to write the original equation first, and then swap the variables from y equals 7x minus 4 to y equals 7y minus 4. Now, we need to solve for the y, which gives us the final answer of y equals x plus 4 over 7. And there you go. Remember, if both the original relations and the inverse relation happen to be functions, the two are called inverse functions. That's it. Thank you so much for listening. I hope that you learned something from today's presentation. Stay safe and bye!